Welcome back everyone to the Hello World Guide. This is another episode of the Android game development series, and in this video we are going to add the collision of our ball with the other entities in the game. So to do that, the first thing I've done is that in the game object I have added a separate collision radius. Now this might not be needed since we already have the size, but our ball is going to be, we are going to make it defined as a circle instead of just a AABB box like this size suggests. So since the ball is a circle, it will be better to have a radius here, and we are going to call this collision radius. And anything that has this collision radius, we can specify it to actually cause the game to detect and process collisions, and then this callback will be called. Now this is called the on collide callback, just like on update and on touch, and this takes a game object reference and a game state, of course, like everything else does, but it also has another game object reference, which is the other object that we hit, as well as a vector2 for the difference between the closest point we hit on, as well as the the difference between the closest point that we hit on and the center of the other object, and we'll get into this a bit more in a second. Now let's go under game.cpp, and first of all let's look at the update function. Inside of the update function, after we are doing the update, we also need to check if our object has an onCollide method, and we only need to do the processing if it has that. If it doesn't have that, we don't need to do all of this. Then we need to loop over all of the objects again, and we'll call this other this time. And the reason we are looping over again, because we need to check collision against everything else. And while this is not really optimal in the sense that not every object can collide, something like having a more complex algorithm, or a space partitioning algorithm, that will not really be necessary for such a small game. So we are going to just go over each other object, and then if the object addresses are same, that means we are checking the same object, so we don't need to compare them, so we're going to just continue. And if they are different, then we are going to first of all calculate a difference. Now this difference is going to be between the centers of both objects, so the object dot position minus other dot position. And after we get that, we are going to clamp this difference between the basically the extents of the box. So this size is the whole size, so negative other dot size minus 2 divided by 2 means that we are going to take the negative half size and the positive half side of the other object, and then we are going to clamp this difference value between that. Now this will give us the the maximum difference to the object that we can have, because if anything beyond, then that means that we are actually not within the object, so we are going to get that difference by the clamped value. Then we are going to take the position of the other object, and we are going to add this clamping into it, and that will give us the closest point that we actually hit on. So that's basically the closest point of collision. So this was the center of the object of the two objects colliding, and this is the closest point where the collision happened. And then this closest difference is the difference between the closest point and the position of the object, so basically how far it is from that. And yeah, that's pretty much it. And the next thing that you can see here is that we have got our length. We take the length of the closest difference, which is the magnitude, and if it is less than the collision radius, that means a collision has occurred. So if that is the case, which means that a collision has occurred, then we are going to call the object.onCollide function with all of the appropriate parameters. Now let's look at the collide function for the ball. Now inside of here, first of all, I set the collision radius to half of the size to match the shape, and actually this is not necessary. And what we do here is, inside of the onCollide function, we take all of the parameters, and here we create a an enum for representing different directions. We'll have a use for this in a second: up, right, down, and left, just for constants. And then we create an array of vector of directions, and this is just going from all of the same order as this one, so up and right, as well as left, and then down, and then left. And after that, we first need to calculate where we hit. So whether we hit we were going up when we hit, or right, or down, or left, or basically the direction or the surface of the tile or the player that we hit. Now in order to do that, there are various different methods, but the one we will do is that we'll take basically the dot product with each of these, and the dot product, remember, that signifies how basically how close the two vectors align in direction. So if the two vectors are basically the closest basically the closest direction that our current difference vector is to, that means that is the direction that we are aligned in. So for example, if we get different values of dot product for all four directions, and the highest one is the left direction, then that means that we are generally pointed in the left direction. So we just have a max value, set it to 0 initially, then get a direction, and then we just loop over this, and we set the dot product to getting the dot product between the normalized of the difference as well as the directions I, and then we current direction that is, and if our dot is greater than the previous max value, then we set that, and we set the direction to current I. So here we should have the direction that we are generally pointed in, or basically the general direction of the collision. Now basically we have two conditions, if it is left or right, or whether it's horizontal or vertical. So if it's horizontal, which means it's either left or right, then we first of all flip the x direction. Then we calculate the penetration, which is the amount of how much our ball has already gone inside of the other object. So to do that, we get the collision radius, and then we subtract from that our difference dot x, and we need to take the absolute value, so get the general penetration. And after getting the penetration, if it is left, then we are going to add our if we collide it on the left side, we are going to add the penetration. If on the right side, then we are going to subtract it. And if that is not the case, which means it's vertical, we are basically going to do a same thing but with reverse direction. So up is going to have subtraction and down is going to have addition, and we are going to use y-axis instead of x. So after we do that, there is a small other special condition for the player, and that is because the player is going to have the the player can change the direction of the ball depending on where it hit. So if the tag of the other object is equal to player and its direction is going downwards, we only do it if the direction was down, otherwise we don't really need to do it. And this was just for debugging. We can remove that. And if that is the case, then we calculate how far what is the difference basically between the x value of the player and the x value of the current ball. So we take that difference, then we divide that by the half size of the player's rectangle, and what that gives us basically a percentage. So if it is 1, that means that we hit right at the edge. If it's 0, at the center. If it's -1, then we hit at the other edge. And basically after that, we set our direction x to that, and that allows us to basically the more on the corner we hit, the more our ball's direction will go to the left or the right, or like that. And then we set our self dot direction to normalize this, because we don't want it to go wrong, so we always normalize it. So yeah, that's pretty much it, and that should make it work. So if I go ahead and run this, what you should be able to see is that we get our ball, and we can move the pedal around, and it worked correctly. So as you can see, we've got this here, it collides correctly with the bricks and everything, and you can see I can hit it with my pedal, and you can see it goes around in the correct motion. As you can see, that is working quite nicely. So yeah guys, this is going to be pretty much it for this video. I'll see you in the next one, in which we are going to do the final thing of our breakout gameplay, which is that having the game over functionality, or basically the level reset functionality, as well as making it so that when we actually collide against something like a brick, it actually breaks. So that is going to happen in the next video, so stay tuned for that. Make sure to like and subscribe as well, and share this video with other people, and bye.